Well, this video class is for the derivative and it's 9.4. So I broke this into 2 days because the process to find what's called the derivative is kind of tedious. So today our focus will be on the algebra piece of really, can I find the derivative? And then day 2 will be, can I use that derivative? And then, and then we will use the derivative the rest of the class. We'll also learn some shortcut ways because the process is a little bit tedious. All right, so on this first little part here, it talks about the average rate of change. Okay, that's not a derivative. It's just the average of the rate of change. So what's it changing over time? What's that rate changing? So that is a formula that you'll need for a couple homework problems. It's basically half of the step to a derivative. And so you'll see that because you can see kind of what it has here. And in the derivative, you'll see it's pretty similar, except you have to take the limit. So all right, so the things that the derivative can tell us, one is instantaneous rate of change, okay? So right now, at a specific value, what is going to be my rate? Okay, instantaneous, like right now, right here. So whatever spot you want to be at. It also is the slope of a function at any point. So the derivative can tell me the slope of a function at any point. So I have maybe a parabola and I want to know the slope right here at this time, right here. I could find that with a derivative. I can find the slope of a tangent line. Okay. And remember, a tangent line is like a line that touches your graph in exactly one place. So typically it's on a curve and you touch in one place. That's our tangent line. And so then you can find that equation of a tangent line using that slope, or find the slope to help find the equation. That's what I should go with. So we will learn that in day 2. So the derivative finds the slope. So slope of a tangent line, slope of a function. It is a rate, which is a slope. So you can see that slope, slope, slope. It also, for velocity, for that physics piece, the derivative is the velocity of an object at a time, at a specific time, which x would be your time. But so 2 seconds, what's the velocity of that ball you just threw? Things like that. Okay. It's also the change in y over the change in x. So that should sound like slope. What's the change in my y's over my change in my x's? And basically, that's what you see here. So this is change in y, putting the values into the function. So if I start with value a, right, then my next point will be maybe h values up. So these are just your y's over x's. So change in y over change in x. Okay, so it talks a little bit about the way you label a derivative right here. That little apostrophe is actually called prime or f prime or the derivative. So that's our symbol for derivative. We also might see dy dx, okay? And that's a way to label something that it's a derivative. It's not my original function, it's a derivative, okay? Those are the main 2 that we deal with. I can't think of another at the time. There's one more I know. I did not write it down though. Okay, so this is our 4-step process here that is going to find our derivative. So we start with putting in x plus h into our function. Step 2 is we subtract back off that original function. That's just your change in y. Then we divide it by h, which is your x's, and then we take the limit at that specific spot. So that's how I find the derivative. Now, a derivative is a formula. It is a function that we can use to put in a value, like we could put in different times to get out the velocity at specific times using that function. We could find the rate at specific spots. So maybe you have time on the bottom. So in 2000, 2018, you go up and you can see what the rate was at that time. Then the next 2020, you go up and find the rate in 2022. So you can use that formula for lots of things. I was going to say 19, like it's 22 years ago. Because I'm old. So we're going to focus on the two-step process, or sorry, four-step process. And the directions tell us to put in values as well. My note packet didn't come through very clear on my notability. So this is saying f prime of 1. I don't know if I'll get to that piece or not, but that's basically just put the numbers into your answer. Okay. So let's look at this first function here. I can look at this and know the derivative, and you will get to that spot within a month where you can get the derivative a lot faster. But let's go through our steps. So step 1 tells us to put in x plus h into where your x's are. This function only has one x, so we'll put in that x plus h there. And we can simplify this. Xh plus, 9x plus 9h. Said that wrong. Plus the 4, there we go. So then step 2 says subtract off the original function. So right now I have 9x plus 9h plus 4. I'm going to minus off the entire original function. You have to use parentheses. You have to, or you'll mess up your negative signs and get the problem wrong, because I'm subtracting off the 9x and I'm subtracting off the 4. So make sure you use a parenthesis there. So then I'm going to change this to positive. That changes that to negative and that to negative. Now I can combine like terms. So I see a 9x here and a negative 9x here. So those will cancel. Positive 4 minus 4, those will cancel. They almost always cancel something somewhere. If they're not canceling, you might have made a mistake on your simplification. Step 3, divide by h. So I have 9h, I'm going to divide by h, and those h's will cancel, so I actually just have 9. Last step is then to take the limit as h approaches 0 of 9. Now, what did we do when we had a constant value of a limit? So I'm trying to find, like, where is it going from both sides, right? If I'm just at 9, it's at 9 on this side, it's at 9 on this side. The answer is just 9. I don't have anywhere to put the 0 in. There's no h's left. So the answer is just 9. So the way that I could write this is the derivative is 9. The derivative is 9. Those are the two ways I could write it, dy over dx or just the prime. This is probably the most common way to write your functions. So I found the derivative and it happens to be a number. Now look up at this function right here. What's the slope of that line? 9. What's the derivative help us find? The slope. So when I have a line, the slope is the same over the whole thing. If I have a parabola or a funky shape, the slope is changing. So with a line, you're just going to get the slope. With any other function, you're going to get a formula. So let's do problem 2, a little bit harder. So let's see here. So our first step is to put that x plus h into that function. Oosh, it's in 2 spots, so it's a little uglier. Okay, remember here when I have this x plus h squared, you have a middle term. It's x plus h times x plus h. So I do a little shortcut to get that middle term. I do the first term x squared, so it's x squared, and then I times the 2 terms together. X times h is xh, and I times it by 2 because there's 2 of those when I do the middle term. So positive 2xh plus h squared. So that's a little bit of a shortcut because I'm lazy, but you could go over here and have x plus h times x plus h, and go x times x is x squared, x times h is xh. You have another hx or xh plus h squared. So you can see where the 2 middle terms comes in, where you times them together. because it's a square, that is the same way every time. They're not, that middle term is going to always be 2 times the 2 middle ones times together. Okay, so then over here, plus 4x plus 4h minus 7. Thank you, Mr. Brown, for that little shortcut over there, by the way. Favorite math teacher ever. Okay, whew. So I'm going to write down for step 2, we subtract the original. I'm going to write down the simplified version of timesing this -2 through as I start my step 2, because I don't want to write it down twice. So I have -2x squared minus 4xh minus 2h squared, timesing the -2 through, plus 4x plus 4h minus 7, minus off the original function, -2x squared plus 4x minus 7. So when I subtract this off, I'm going to make that a positive and change all the signs. That way I can, it's a little easier not to make mistakes that way. So then I can see this is a positive, that's a negative, so those will cancel. That one will cancel, and that one will cancel. So see how I said they always have canceling? They better. So step 3, write down what you have left. -4xh minus 2h squared plus 4h over h. So you cannot take the limit and put in a 0 for h when 0 is in the denominator. So it would become 0 in that denominator. It's going to be 0 over 0. So you have to simplify out the h, or it's in indeterminate form. So I'm going to take an h out of the top, and I'm left with -4x minus 2h plus 4. And then I could then cancel the h's. So now I can go on to step 4, which will be to take the limit as h approaches 0. That's an ugly arrow. So when I find the limit, I'm putting in 0 for h of my function. So my answer is going to be -4x plus 4. So I would write that as the derivative of this function is -4x plus 4. So that is a formula, get to sneeze, that I could use to find the slope. Okay? So I would have to have a value or velocity, any of it. Maybe at 2, what's the slope? So you put 2 in. So anyway, that was covered. I was like, I'm gonna sneeze. Okay. So just go slow, watch your algebra, make sure you don't subtract and add the wrong things. You can really catch a lot of your errors when you don't cancel. When things aren't canceling, you've like, oh, I did something wrong. All right, so my next one printed like super ugly. This is the function of 1 over x. So I'm going to do 2 more that are ugly. Hold on. All right. So this one is a rational function, so it becomes hard because you have to bring in adding ugly fractions. So step 1 says put in the x plus h. So 1 over x plus h. Can't really do much. Step 2 says, what do we do for step 2? Subtract off the original. So 1 over x plus h minus 1 over x. And unfortunately, now we have to combine these by actually subtracting them together. Well, then I have to have a common denominator, so that's a little harder. So common denominator is, you can't just add plus h or whatever. It is timesing them together. So I am going to have a common denominator of timesing those 2 functions. So each fraction will be over x times x plus h. X times x plus h. So this first function has to be times the top and bottom, change colors, has to be timesed by x on the top and bottom here. And this one by x plus h by the opposite there, in order to get that common denominator. So up here, 1 times x is x. 1 times x plus h is x plus h. All right, and we're subtracting. So I have rewritten them with the common denominator. Now I could combine them by subtracting them. Be careful to think again, as that's a minus the whole thing. It's not just minus the first term. So from here, I am now going to have x minus h over x plus h. But then you can see x minus x on the top can cancel. So I'm down to negative h x plus h. Whoosh. Step 2 is now done. Can't really simplify anymore. I mean, I could times the x through, but it doesn't matter. Okay, so step 3. We do what for step 3? Divide by h. Where does the h go? Numerator or denominator when I'm dividing by it? The denominator. So I'm really just going to add an h to the denominator to say divide by h. So I have negative h on top. Now in the bottom, I'm going to have h times the x plus h. I do not need the dots. I wrote them just to help you know it's times. So the h's will cancel, but this is a negative h on top. The negative h will become what when they cancel? Negative 1. So negative 1 over x plus h. Almost done. Now, last step. We get so excited. We got all those 3 hard steps. We sometimes forget. Our last step is to take the limit. Ignore this 4. Sorry, problem 4 didn't come through. Take the limit as h approaches 0. So I'm going to have negative 1 over x. Oops, I put 0. I don't know why I put 0. X plus 0, right? When we put that 0 in for h, because limit is put the value in and hope you don't get 0 over 0, or you have to do something extra. All right, so from here, then it's just going to be x times x on the bottom, so I get x squared. So this is your derivative here. And I wrote that derivative simple ugly. When you write with an Apple pen, not always pretty. All right, so that's your final answer. That's an ugly one. I guess I could leave that 4 there, step 4. Okay, so for this next problem, I'm just scrolling down past these because I added a page to be able to do problem 4 because it's a little bit long. And it didn't come through on my note packet, so hopefully it does. I have to double check the one online. So this is the square root of x plus 2. So this function is a lot harder because when we go to do the limit at the bottom, it's in an indeterminate form. So it's bringing out all those things that we've been learning with limits and then adding all these extra steps to do this derivative. So step 1 on this derivative, again, add the x plus h. Okay, step 2 would be subtract off the original function. Plus 2, now minus off the entire original function. Okay, so change your signs, and I can see these will cancel, but these don't, which is fine, just one thing canceled. So in step 3, I now have x plus h minus square root of x over h, right? Divide by h, third step. So it looks like we should be done, and we can move on to step 4, where you take the limit as h approaches 0. Because I can't cancel my h with anything on the top. You can't cancel under a radical and a minus connected. Nope. It would have to be out front of everything. So when I go to do this, it's 0 over 0 or indeterminate. What are the 2 things we can do to rewrite this function so that we can actually see the derivative or the limit? So we can factor. Okay, I look at this and go, well, but I can't factor that. Or conjugate. And unfortunately, we're in door number 2. So we're going to have to use a conjugate. Okay, so right now, we have the square root of x plus h minus square root of x. Think of this as a big parenthesis, and we want to times it by switching the sign in the middle. So it's going to be the square root of x plus h plus the square root of x, right? That's our conjugate. Now times that by the top and the bottom. And we'll multiply this out, and then it will be in a different form that we can then take the limit of. So first, for FOIL, first, outer, inner, last. So first two multiplied together, I have the square root times the square root. So we can times what's underneath, which is x plus h times x plus h, which is x plus h squared, right? When we times them, and the square root of a square, they kind of undo each other. So we just have x plus h left on our first two. You can write that out if you need to, but basically you can times the bottoms and they become squared. Okay, then this one times this one. You can't do much with those because they have different terms underneath. Well, I mean, no, you can. I lied. Hold on. It's times, so it's x plus h. Because they both are square root, not a third root and a square root, you can times what's underneath. So times those together, and then minus the same idea, x times the x plus h underneath. And then the last two, x times x is x squared, square root is x. So I have minus x all over. H times this first term is going to be h. Well, maybe I'll leave it factored. We'll have to factor it out. I mean, you could times the h through, but then you're going to have to untimes the h through, which you would know. But excuse me. But I'm just going to leave it that way. All right. So look at the top. This one and this one will cancel. These two cancel. So I really only have h, which will cancel with this h. So I have nothing left on the top. So I leave a placeholder of a 1. Okay, now I can take the limit as h approaches 0, put the 0 in here, right? And I'm going to have the square root of x plus the square root of x. What is the square root of x plus the square root of x? Well, when I add, it's like saying I have one of them plus one of them. So it becomes 2 square roots of x's. Okay, they have to be exactly the same to add them, and you add the numbers in front, which was 1 plus 1. Final answer. Yay! Okay, so this one is definitely harder, and you have one like this in your homework. So what I want you to do is skip the first couple questions that are about limits and derivatives in general, and I want you just to focus on doing the homework problems that require just the derivative. Okay, just practicing this 4-step process. So you have 2 days to do this homework, and I know it'll take you some good time to get this process down. So day 1, just work on that, and I will make a second video for day 2.